All right, so the first one's empirical formula. On your test work page, you got this picture right here. So the mean goes in the middle. And then you are going to, so 36.5, you add the standard deviation as you go to the right. So I add 5.2 and get 41.7. Add 5.2 and get 46.9. Add 5.2 and get 52.1, okay? And then as you go to the left, you're going to subtract the standard deviation. 31.3, 26.1, and 20.9, okay? This is just to help you remember that, okay, as I go one standard deviation away, it's 68%. As I go two standard deviations away, it's 95%. As I go three, it is 99.7%. So this will help you do this. I'm going to do that. When you do this, so now to go answer the problem, actually, this should be easy from here. This one would be 36.5. This one is between 50 and 55, so that's got to be that 52.1. And then this one is between 20 and 25, so that's got to be that 20.09 or 20.9, okay? So those are three standard deviations away, right? That's this number and this number. So if I go three standard deviations away, that's 99.7, okay? So you just got to look at how many times you add it, how many times you subtract it, and figure out which ones go on that number line there. There are some test work pages floating around somewhere if you showed up late. The next one is a z-score problem. There is one trick to this one. Maybe it'll be, where's that? Okay, the first thing, like I just checked this just because I know this problem, but this clearly bell-shaped. This means you can compare z-scores, okay? If it said clearly skewed, then this is going to be your answer for part B, okay? You cannot, it's unclear, you cannot compare them if it's skewed. So that is the first thing you want to check, or the last thing you want to check, something that when you're doing part B, you can only compare them if it is bell-shaped. So if skewed, part B is unclear. All right, so now for Arturo's, we're doing the sharks. Arturo is 2.5, Arturo 2.5, and Arturo is a male, so we want the male numbers. So for the formula, I should have put this on the test worksheet, but I didn't. It is x minus the mean divided by the standard deviation, the data value minus the mean divided by the standard deviation. So for back to Arturo, we have he's X. Where's my male numbers? Male 3.98, 0.4, 3.98, 0.41. So his Arturo's length minus the mean for the males and the standard deviation for the males. 2.5 minus 3.98 divided by 0.41 is, wow, negative 4.34. So Arturo is super small. I know it's super small because it is negative, right? It's well below the mean. That seems almost too small, but something's not right. Let me double check that. 2.5 minus 3.98 divided by 0.41. I think I clicked something wrong on my calculator. Well, usually it's not over 3, but I'm still getting 3.61. That looks better. Okay, let's do Lulu's. Lulu is 4 meters long, and the Lulu is female, so female is 3.65 and 0.17. So 4 minus 3.65 minus 0.17. Well, Lulu's going to be positive. Sorry, I'll make sure everything's right. Usually the numbers are closer together. So Lulu is bigger than the mean, and Arturo is smaller than the mean. So do that in the calculator, and you get 2.05. So that's those numbers for part B, which is larger. It's obviously Lulu because she's bigger than the mean. Again, you can only compare this if it's clearly bell-shaped, okay? All right, I don't think y'all have too much problem with that one. It is kind of, if you miss that bell-shaped one, it makes you mad, but all right, on this one, you do have to use a calculator. This is a normal distribution problem. According to a recent survey, the salaries of entry-level position at a large company have a mean of 41,000, standard deviation 7,500. Find the proportion of employees at entry level at the company who are at least 48,000. Okay, so I'm going to put this in the calculator and get my answer, and then we'll kind of come back and talk about it. So you are going to use this one because you're finding the proportion. You have to find the z-score. So it says P of z, so I need to find the z-score. You're doing what I just did right there. So we're doing 48,000 is the number we're looking at, minus the mean, divided by the standard deviation. Oops. Divided by the standard deviation was 7,500, okay? But this is less than or equal to. I want at least 48,000, so what do I need to do? Do the 1 minus, okay? Let me type this number in real quick here, and then I'll go back and 0.2023. All right. So what you are looking at here, just to draw a picture, I may not draw a picture on everyone. Whoa. Like my mean right here is 41750. It's always nice to have the mean because you know where you're at. I want at least 48,000. So that is saying at least I want the right side, okay? If you draw a picture like this, and is this on your work page? I forgot about the work page. This one's not? No. Is this number 4? Are you sure this one's not on your work page? Yeah, that's this problem, isn't it?
Yeah, but it's not asking for us to draw that out.
Oh, it's not asking you to draw. Okay, I get what you're saying. Okay, that's why I was confused. All right, so on this one, it is nice to draw the picture. I probably should have made you draw the picture on this one just because when I draw this picture, just put the mean there and then greater than 48,000 because it says at least 48,000, okay? Just by looking at the picture, I can kind of tell. This is 20%, right? This is 20%, about 20%. So that makes sense that this is about 20%, right? Like looking at the picture kind of makes sure you get the right answer. So that helps you, remind you to do 1 minus to flip the sign. So we do 1 minus to flip the sign, 1 minus. Okay. So I think drawing the picture is just nice to like verify you got the right answer. If you forget to flip the sign and it's 80%, well, that blue shaded area does not look like 80%. So you can go back and kind of double check your answer. You definitely don't have to. All I want to see in the test work page is this right here. Okay. Technically, you could do this first and find the z-score for that and like do that separately. But if the calculator can do it all at once, I just kind of do it all at once. Does that make sense what I was saying? Like you could do... Oh, I can't go back. I could go ahead and do like 48,000 minus 41,750 divided by the 7,500. That's my z-score. Okay, and then just put that into the button and then do 1 minus. Like you can do it. Find the z-score first and then put it in. Okay. All right, next one is the same type of problem, but the difference here is if the producer's claim is correct, what's the probability that the mean weight loss after 1 leak on this pill for a random sample of 60 individuals will be 1.9% or less, or 1.9 pounds or less? Okay. On this one, the difference between this one and the last one, first of all, is find our z-score. We're doing 1.9 or less, so 1.9 minus 1.85 divided by 1.02. I am sampling 60 people. If you ever pick more than one person, if I'm doing the sample of 60 people, I got to compare the average of those 60 people to the other average, okay? So I need to divide by the square root of n. Divide by the square root of 60. I suppose if y'all remind me, I'll write these formulas on the board. The other class didn't remind me though. But when I sample more than one person, I have to divide by the square root of n. I won't write that on the board, but I will write the separate formula on the board. So if you ever sample more than one person, the difference between this problem and the last problem says we randomly pick one person that's greater than 48,000. This one says we're randomly sampling 60 people, so I had to divide by the square root of 60. Everybody with me on that? If you ever sample more than one person, you have to divide by the square root of 60. And this says pounds or less, so that should be correct, right? That should be our answer? No. So it should be 0.6479. I'll do it. I'll screenshot it real quick. And again, this is one that it does not hurt to draw the picture. Anytime you use that P button, just to check your answer. My mean is 1.85. I am sampling 1.9. 1.9 would be on this side. That's why I do this. And I want less than. So that makes sense that would be about 60%, right? Because the black line is half. So that's 50. So it's going to be over 50%. Just nice to check that real quick. And this formula, if you want to see it written out, just because it's the square root of n. And I'll go ahead and write this. Use when sampling more than one. So sample of 60. Anything else? Yeah, it looks good. I guess I'll write 1.9 pounds or less. All right, next one is on your work page. It does have a confidence interval problem. All right, so you take a sample, you do a sample, you're testing the confidence interval here. I think somebody from this class might have emailed me. No, it was the last class, but I think we talked about this. Somebody showed me last class how this thing covers it. So these numbers never change. So if it is covered on the test, did anybody run into that error? Or that undo sign was like covering it? Those numbers never change. So if it's covered on the test, just tell me and it'll be 2.576 is the one that's covered. So I'll write it on the board. Okay. All right, so the sample size, we had 45 phones. Our point estimate is 6.15. The population standard deviation is 2.73. The critical value, okay, we're doing the 99% confidence interval. So we will write this on the sheet in just a second, the test worksheet, but this will help you find it. That kind of is there to help you find it. If there's 99% on the inside, that means there's 1% on the outside. So there's 0.5% on each side, right? So this is that 0.005. I'll write that formula out in just a second when I screenshot it. But again, 99% on the inside, so that's 1% on the outside. So there's 0.005 on each side. So you click compute. To plot this, we are going to do the 99% confidence interval. Down there, it is 6.15 plus or minus 1.06. That is taking 6.105 plus 1.06 and 6.15 minus 1.06. So I get 5.09 and 7.21. The manufacturer claim was 5.66. So we did our sample to see if the manufacturer is lying. Their battery is lasting at 5.66. That is inside. It does not contradict because it is inside. By the way, the answer on this one is always A or D. Because those are the only ones that make sense. If it contradicts, it's on the inside. I'm sorry. If it doesn't contradict, it's on the inside. I know this is harder for you to see when I turn it like this, so just give me a second. If it doesn't contradict, it's on the inside. If it does contradict, it's on the outside. So that answer is always A or D. Same for like the next 4 or 5 problems. It's always A or D. Like it's never B or C. It's always A or D. All right, so this right here, the formula that I always use for this is 1 minus the confidence level divided by 2. So 1 minus 0.99 divided by 2 would be 0.05. That tells me to use this one. So if you want to remember that, the way I tried to help you remember that is with your test worksheet. Try to find a spot to write this. But what this is saying is write each one. No, that person that I'm looking at did it wrong. it would be 2.576, and this would be negative 2.576. Label the bell curve with your positive and negative critical values, shade your confidence level. So this would be a big number, it's positive and negative, and what this is saying is that this right here accounts for 99% of that thing shaded. A negative 2.576 and a positive 2.576 would be 99% on the inside. Does that make sense? So that's kind of what I'm looking for on that test work page. And then this is 6.15 plus 1.06, which is 7.21, and 6.15 minus 1.06 is 5.09. Does not contradict on the inside. Should be good. Next one, number 6. Number 6, again, you click take a sample. The sample size, it tells you up there is 65 scratchers, but you can add up 26 and 39, your winners and losers. So that is 65. The point estimate is, I guess we're trying to figure out how much won, so that's 0.4. Probably should read it. Follow the steps below to construct a 95% confidence interval for population proportion for all winning scratchers. Okay, so we do have the point estimate. There it is. See right here is covering up my, oh no. Can I undo my delete? Yes, okay. 95% confidence interval. So again, 95% is on the inside, 5% is on the outside, so 2.5 on each side. So that's going to be the Z.025, 1.96. So now we get our number here. So this is 40% plus or minus 12%. That's a big margin of error. So 0.28 and 0.52. But they're advertising that it's 56%. They say 56% of scratchers working, but our sample is 65. We're 95% confident that only between 28 and 52% are going to work or win. So yes, it does contradict. We are going to contradict. Okay, I'll just screenshot this one. I don't think there's anything extra I need to do on this one. All right, real quick. Confidence level 1 minus 0.95 divided by 2 is 0.025. So that's this number. The screen just flashed, didn't it? Flashed black. I think my cord's dying on me. Good thing this is the last time I use it for the semester. All right, the remainder of the test is probably hypothesis testing for number 7 on your test work page. I told you to match the inequalities that go with it. So really, you don't have to have the problem. The null hypothesis is always equal, so the equal sign goes under the null hypothesis on your paper. I can write this out in just a second. Oh, wait, I can show you from my other class. So like right here, the null hypothesis is always equal. That's HO. The alternate hypothesis is H1. That's where you read the problem, and it's going to be less than, greater than, or not equal to. Okay? So that's how you read the problem. So you're supposed to match those inequalities, which one they go under there. This is something that would be nice to do as soon as you get your test work page on Thursday, because then you have your answer right there, and it's kind of a note to refer back to. And actually, number 8 is the, you could do that as well. You don't need to read a problem there. Number 8 is you use a 2-tail when it's not equal to, and if it's a 1-tail, it's less than or greater than. Okay, the less than would be the left tail, the greater than would be the right tail. So those two at the bottom, you don't even need to look at the problem to answer. Kind of some notes to help you there. All right, I guess I need to go back here. All right, so this is the easy one. Don't miss this one. This helps you do it. It gives me the null and the alternate right there. It's not equal to, so it is a two-tail test. The critical values are right there given to us. 1.645. The test statistic is right there, negative 2.324. So now we can look at it and say that this z-score is in the rejection region. So if it's in the rejection region, you are going to reject it. See if I can get... All right. Just real quick, what we said here, not equal to would be a two-tail test. And then you just get the information from right here. But then you have this is in the rejection region, so you reject. The next one has to do with the p-value, but same kind of idea here. You have greater than, so this is a one-tail. My test statistic is 1.385. So we are going to shade on the greater than side. That would be the right tail. My p-value is given to me at 0.083. So make sure that makes sense. 8%, that looks like about 8% of that whole thing is shaded. So now we compare this. I'll write out this chart in just a second. What are we doing? 0.05 level of significance. So the p-value is greater than. When it is greater than, it is not rejected. I wish I wrote that right there. I'm just going to do this. Oh, man, I can't get it all in one. So this is something that you will have to remember for the test. This is just part of the learning, that you got to know this, which is just one of the things. You actually will see p-value some point in time in your life. I don't really know why, but you will. Level of significance. So the rule here, or I guess the rule is p-value is less than p-value is less than the level of significance. Or the p-value is greater than the level of significance. You have these options, HO, H1, HO, H1. You would say you reject if it's less than. My goodness, why can't I write an R? Reject. And there is evidence to support this one. So that one is correct. It's the opposite on this one. So you do not reject. There is not evidence. Okay. So the p-value is greater than, it is not rejected. This is p-value, level of significance. My level of significance was 0.05. My p-value is 0.083. So this is greater than. So it's greater than, you do not reject. And again, on this one, I know I said this, but said it a couple problems ago. The last 6 problems, B and C are never an option. It's always A or D. Anything else I need to say on this? One tail would, because it's greater than. That's it. All right, now you actually got to work a problem out and do the full one. They don't give it to you. So we got a knee surgery and how long it takes to recover. Is there enough evidence to support the claim that the mean recovery time of patients who practice this new style of physical therapy is less than 12 weeks? So the first one is always going to be equal. The next one, you read the problem, it says less than 12 weeks. Okay, so that one you come up with. Now we have to find, this is a one-tail test because it's less than. We have to find the test statistic. They give you the formula. By the way, that's the same formula for number 4. So if you forget, there it is right there. So I don't really need to write it on the board because that's the same formula for number 4. It actually works for number 3 too because the n is 1. All right, so let's put this in here. It is less than, so I do this. we're going to do X. X is 12 weeks. They're saying that the average is, scroll up a little bit, 11.7. The standard deviation is 1.4 divided by the square root of how many people did we sample? 54. We did 54 knee surgeries. My mother just had knee surgery, so I'm going to send her this problem. Be like I was talking about you in class today. All right, less than 12 weeks. Everything looks good there. Oh, we actually need that test statistic number, don't we? Man, I just found the p-value. Now I got to go back and find 2.942. We can double check it, I guess. So you actually have to find the test statistics, so we got to go back and do that. Yeah, I was doing it all at once. Minus 11.7, wasn't it? Divided by the square root, 1.4, divided by the square root of n, which was 54. So my test statistic is 1.547. We're going to shade this side. That p-value looks way too big, huh? This is why we do this. What's wrong? Because it's negative. It is negative, so I shaded the wrong side. How about that? That looks better. That looks like 94%. It is not negative. I'm sorry. It's not negative. It's less than 12 weeks. Okay, let's just double check everything since I got confused there for a second. This is how you double check everything. The average is 11.7. I got 12, right? So it's going to be more than 50%. It's going to be a positive number. It's going to be a positive z-score because it's bigger than the average. And it's going to be more than 50% because it's bigger than the average, okay? So my numbers are kind of crazy, but everything looks good there. Does that make sense a little bit? A little bit. I'll kind of write it out in just a second. All right. So now we compare the p-value to the level of significance. My p-value is really big, so it's going to be greater than. That means it's going to be D. It's greater than, so it is not rejected. We can double check this, but you want less than 0.94. Okay. Screenshot with that in there. Okay, so give me 1 second just to make sure this is like why it is nice to know about that, the normal curve and the different things there. It makes it so much easier to understand. So my mean is 11.7, right? We got 12, which is on this side. So that means, and I want less than, because we are looking then less than 12, right? All right. Less than, where's it at? Less than 12. So that tells me this, by knowing this, that 12 is greater than 11.7, that means we're above the mean. I'm just using normal people terms there. So that means you're going to have a positive test statistic, and the p-value is going to be greater than 50%. I hate writing the p-value is going to be greater than 50 cents. That is true. We'll say, I don't like putting that. That's only true because we're finding the less than, right? Because we're going to the left. So we wanted it to be less than the mean. We ended up with a number greater than the mean. That makes it 50%. All right, last thing here on this one. My p-value was 0.942. My level of significance is 0.10. That is obviously greater than, so you do not reject. There is not evidence. Last one. This is the least fun one, though, I think. So same thing, but we're doing a proportion. Oh, man, we got less than 23. I feel like I need to go back. I'm going to regenerate one of these real quick. Because I do not want... Come on, click it. I don't want to not do this whole review without you getting one type of problem real quick here. So I'm going to generate it until we get that one real quick. It won't take long. Perfect. Got it on the first try. Okay. So on this one, it says, complete the parts below as a perform a hypothesis test to see if there is evidence at the point 10 to support the claim that the proportion of all software engineers who rate the company they work for as a great place to work is not 91%. Okay, so the first one, they use P, right? P, it's always equal 0.91. Okay. The next one it says is not. So that's going to be not equal to 0.91. All right. The first thing you got to do is check to see if you can do the hypothesis test. So you do N times P. N times P would be 0.91 times N, which is 220. We surveyed 220 people. So that is 200.2. Okay. And then you do, if 91% say that it is a good company to work for, that means 9% say that it's not, right? So 0.09 times 220. So you do how many people said yes times the total amount, how many people said no times the total amount. To make sure your numbers are good enough, those numbers both need to be greater than or equal to 10. It tells you that in the directions. It's always going to be greater than or equal to 10. But it's just what percentage said yes times the total amount, what percentage of people said no times the total amount. Check and make sure your numbers aren't too far apart and that you're sampling enough people. Okay. So we said is not. So this is a two-tailed test. So we are going to have two critical values. Our critical value is based on the level of significance, very similar to what we did with the confidence interval. 90% is on the inside, 10% is on the outside, so you got 5% on the left. This sentence right here tells you what to do, basically. So you're going to use that button on the calculator and 0.05. My one on the right, this is positive, so it's on the right, 1.645. All you got to do is the one on the left is the same thing, but it's going to be negative. Okay? This is going to work if it's the left tail, you'd only use a negative. If it's the right tail, you only use the positive. If it's both, you use both. Okay? If it makes sense? Now my test statistic. This one I do have to do that big crazy formula. The way that I do it, I'll show you. I hit the division bar twice. So I do the first division bar, but I'm going to go ahead and do the second one because 204. 204 out of 220 said yes. So that's my proportion. Sorry, I got my phone calculator right here, but 204 divided by 220. We think it's 91%. We did this survey. 204 out of 220 is 93%. Okay? So you can find that first if you want to. I just do it I just do it like this so I don't have to round. And then I do the square root. I'm going to hit the division button again. We're doing 0.91 times 0.09. How many people said yes versus how many people said no? Divided by how many people we sample is 220. Okay, everybody good on that formula right there? That is, no, you're not good on that formula? So the P is the number you're arguing about, and then the P hat is how many you sample. I'll kind of write it out again in just a second. Let me get the number real quick here. All right, so we have our test statistic. We have our rejection region. Why didn't it make my rejection region, though? There we go. So my test statistic lands outside the rejection region, so it doesn't fall in the rejection region. There's not enough evidence to support it, okay? Again, it's either A or D. So let's go back to this formula real quick. That's kind of where the confusion is. That is, I told you this is the hardest one to end it on, and it is because of that formula. So let's write it out real quick. And then we can be done. This is 0.895. All right. So the first thing right here on this formula is P hat. P hat is 204 divided by 220. That is our sample, how many we sample, okay? You are welcome to do that first and put it into the formula, 0.927. I just write it like this so that I don't have to round anything. It should still count it right if you do 0.927 though, okay? So this formula is 0.927 minus the P we should have from up here. This is my P, okay? So it's minus 0.91. And then we are going to divide by 0.91. If that's 91%, this has got to be 9%. You are welcome to put in the calculator also, though, just like it says. You are welcome to put it into the calculator. I'm kind of giving you an alternate way of putting it in the calculator here. But you're welcome to put it in the calculator just like that, and then divided by the square root of n. The square root of n is how many people we sampled, 220. I'll change colors there. Square root of n is 220. That's coming from this number right here. Okay? Now, I kind of showed you how to put that in the calculator, but that is an alternate way of kind of putting it in the calculator. That formula is the hardest. It is going to be given to you, but you do have to make sure you do that correctly. So the P hat is your sample. That's your keywords there. Whereas the P is your, and that says that right here, by the way. Oh, I probably covered it up. It says it in a couple spots. P is the population proportion. That tells you that that is the number that you're arguing about. Of course, I covered it up. It's right here. Proportion P, and it's like right here. Okay. Oh, no, it's right there. It's right here. All of that's right here. I already got it circled. Okay. So that's how you find the P and the P hat. It is just kind of hard to put in the calculator, and it's not fun. I wish there was a better way to do that. That's like the one thing that I wish Alex had, is that one formula. They didn't have everything. Do y'all want to watch me put it in the calculator again? Like if you, just to do it one more time, I always hit the division bar first. If you want to change it to 0.927 first, that makes it easier to put in the calculator. It just stops you. You have to round it. And then once I get to the division, or the inside the square root, there's another division. So before I start typing, I go ahead and make a fraction bar. And this just kind of makes sure that you multiply everything in the right order. And then you can do a parentheses, 1 minus 0.91. So it looks just like the formula right there. So you're welcome to do it that way too. And rounding it made it a little bit off, but it will still count that right. Okay, we'll even double check it to make sure. Did I do everything? Oh, no. I hope it counts it right. I'm going to be real mad if it doesn't. Didn't count it right. No. Well, it should count it right. Did I do something? Let's double check this real quick. 204. I know y'all are ready to go. Divided by 220. 0.927. Did it really not count it right? 0.927 minus 0.91 divided by the square root of 0.91 times 0.09. Did I type in the right 220? Whoa. Oh, I did the square root of 220. Well, if you missed that on the test, tell me, and I can't believe it counts it that far off. Or made it that far off. If you get that wrong on the test, I can definitely give you points. Computer math is not perfect. Okay, maybe just round more than 3 decimal spots. I kind of got a weird one that was 927, 27, 27, 27, 27, 27. So maybe put more than 3 in and it should work. Oh, I forgot a 7 right there too. Yeah, I just rounded it too much, okay? Put more than 3 and it will work. Let's try 4, 5. See, 5's enough, okay? I think as long as you do, just don't do 3. 3's too many, okay?